Hello and welcome back to Hidden in the Stars. Something you may have heard of in astronomy is Hubble's Law. But what out of this world is Hubble's Law? Hubble's Law, also called the Hubble-Lemaître Law, is named after American astronomer Edwin Hubble and Belgian Catholic priest, mathematician, and physicist Georges Lemaître. It was created in 1929 by Edwin Hubble, but in 2018 the IAU voted to rename it to include Lemaitre due to his French article describing the idea of an expanding universe. In this article, he predicted that galaxies would move further away from Earth at speeds proportional to their distances by using Einstein's theory of general relativity along with his observations of distant galaxies. Hubble's law was announced in Edwin Hubble's 1929 paper on the expansion of the universe. It was called A Relation Between Distance and Radial Velocity Among Extragalactic Nebulae. Ooh, what a fun name. Don't worry, it's not all that different from Lemaitre's article in 1927. While the article was about a relationship between proportional distances and speeds of receding galaxies based on visual observations, the paper was about a relationship between distances and visually observed velocity, displacement over time, along a line of sight of extragalactic nebulae. So, what you should really take away here is that the differences are in that of speed versus velocity and what is being observed, a galaxy or extragalactic nebulae. But velocity is just displacement over time, and speed is just distance over time. Does that make a little more sense? To get back to it, Hubble's law essentially states that a galaxy's recessional velocity is directly proportional to its distance from Earth. It's written as v equals h sub 0 times d. The only uppercase letter here is the h because we know that most of the time uppercase V is volume. We are not trying to find the volume of the universe. Trust me, you don't want to go there. This was derived by plotting galactic distances against the redshifts. If you're not too sure what a redshift is or you're a new viewer, go check out our video 1 shift, 2 shift, redshift, blue shift. What Hubble found was a linear, notice the equation is linear, relationship between the velocities and distances, v and d, of the galaxies. However, life can never be that simple, can it? It can't just be v equals d and be really nice, or say v equals 2d. Nope, never. Someone, somewhere, sometime looked into deep space, saw a bell rock, and told numeric coefficients, "You cannot pass," and slammed a quill. The only things that got through were the letters. And thus the Hubble constant was born. The Hubble constant, or h sub o, remember capital H, is the constant of proportionality. It measures the rate at which the universe is expanding. The Hubble constant is determined by calculating standard candles, things like supernova and Cepheid variables, gravitational waves, and analyzing the measurements and intensity of the cosmic microwave background, which we also have a video on. The Hubble constant also helps to provide an approximate age of the universe. Currently, it's a debated 67 to 70 kilometers per second per megaparsec for the early universe, and 70 to 76 kilometers per second per megaparsec for the current universe. These two scientists both had the same findings, which had to lead to the same conclusion. The universe is expanding everywhere. But how do you envision that? Not like a balloon. Don't envision the balloon thing. People envision the balloon thing and just don't do it. A really good analogy that I learned is the chocolate chip muffin analogy. You're making a chocolate chip muffin, right? You know the consistency, so you know how all the chocolate chips sit kind of suspended in different spots so that they all just don't come together or fall to the bottom of the mixture, as long as you mix it correctly. As you bake it, what happens? Where do the chocolate chips go? Does the muffin only expand in one direction? Well, imagine that it's not being constricted by the muffin tin and it's just allowed to do whatever it wants to do naturally. It's going to expand in all directions, right? If you think about it. And it's not like it has instructions. It's not going to uniformly expand in all directions. One way may expand a little more than another way because there was uneven mixing or a chocolate chip was in the way. Now think about the chocolate chips. Where did they go? Did they stay exactly where they were, or did they expand with the mixture? They expanded with the mixture. They weren't anchored down to wherever they were in place relative to the mixture. But the farther apart the two chocolate chips are at the start, the faster they will be moving away from each other as the mixture expands. Take a second and try to imagine baking that muffin. Now that you've imagined baking your fun muffin, know that there is no single center point in our universe or in this expansion. Your theoretical muffin has no single center point. This muffin represents that the velocity is equal to the Hubble constant times the distance, all discovered by measuring redshifts, and it proves that the universe is constantly accelerating in expansion. Now that you have a better understanding of Hubble's law, go get some muffins. I know you're hungry by this point. Thanks for tuning in to this awesome episode on Hubble's law. Join us on our journey through the cosmos. Catch you next time here at Hidden in the Stars.